So we didn't have much of a discussion about Chapter 1.8 in class, and so I wanted you to review this video. The absolute value in inequalities is something I would want you to review, but on the test we're only going to look at absolute value equations. So the major idea about the absolute value is that you're going to isolate the absolute value on one side of the equation or inequality. And then you're going to break the inside expression of the absolute value into two parts, a positive part and a negative part. And we're going to show you that in just a second. Our first problem and objective is on number 18 on page 184, and it's to solve a one absolute value equation. So in this case, the first idea is to isolate the absolute value on one side of the equation. So to do that, we subtract 2 from both sides of the equation, and we get the absolute value of 2t plus 7 is equal to 20. And then we divide both sides of the equation by 4, and we get the absolute value of 2t plus 7 is equal to 5. Now we break it into two pieces. One is the positive side and one is the negative side. So we have 2t plus 7 is equal to 5, or 2t plus 7 is equal to a minus 5. Notice the inside portion of the expression of the absolute value can either be positive or negative, because the absolute value is always going to make it positive in the end. So now we solve on this side. We subtract 7 from both sides, and we get 2t is equal to a minus 2, or t is equal to a minus 1. On the negative side, we subtract 7 from both sides, and we get 2t is equal to a minus 12, and we divide by 2, and we get t is equal to a negative 6. The solution then is negative 1 comma negative 6, and when we plug it into the original equation, both solutions work. Our second objective is to solve two absolute value equations. This is number 26 on page 184. So the idea here is we've isolated one of the equations, and we always isolate the left-hand side of the equation, and we're going to work with the expression inside that absolute value as being the one that we work with. So there's a negative side, actually there's a positive side, and there's the negative side. So the positive side, we have 2a minus 3 is equal to a positive a plus 2. And then on the negative side, we have 2a minus 3 is equal to a minus parentheses a plus 2. Notice I put parentheses on both of these because the expression inside the absolute value on the second one can also be positive or negative, right? So now we work on the side of 2a minus 3. So 2a minus 3, we will add 3 to both sides. We get 2a is equal to a plus 5, and then we subtract a from both sides, and we get a is equal to 5. So that's one of our solutions. Coming over here, we have to distribute the negative 1, and we get 2a minus 3 is equal to a minus a minus 2. 2a is equal to a negative a plus 1, and so then we end up adding a to both sides. We get 3a is equal to 1, so a is equal to 1/3, and both of these solutions work, so we get 5 and 1/3. So now we have an absolute value, a less than absolute value equation. So this is number 41 on page 185. We start out with a negative 11 is less than or equal to 5 minus the absolute value of 2p plus 4. Again, our idea is to isolate the absolute value on one side of the equation. So we have to subtract 5 from both sides of the equation. When we do that, we get our answer negative 16 is less than or equal to a negative absolute value 2p plus 4. So we're going to divide through or multiply through by a negative 1. When we do that, we have to change the sign. And when we change the sign, we might as well go ahead and rewrite because it's easier to deal with that way. So we get the absolute value of 2p plus 4 is less than or equal to 16. Now you say, well, the less than or equal sign hasn't changed, but it has, because now the 16 is greater than the absolute value. So now we can break the inside piece into two parts, the positive side and the negative side. So on the positive side, we get 2p plus 4 is less than 16. So 2p is less than or equal to 12. P is less than or equal to 6. So there's one of our answers. For the negative now, we have to change the sign. So the sign is 2p plus 4 is greater than or equal to a negative 16 because we've applied a negative 16, a negative to the 16. Now when we do this, we have 2p is greater than or equal to a negative 20. P is greater than or equal to 10, right? So we have our set builder notation where we have p such that negative 10 is less than or equal to p, less than or equal to 6. And for our interval notation, we just have bracket negative 10 comma 6. Our third objective is to solve a greater than absolute value equation. Again, the same ideas apply. We're trying to isolate the absolute value on one side of the equation. So the first step, of course, is to add 4 to both sides. We get 2 absolute value x plus 3 is greater than 10, greater than or equal to 10. And then we divide by 2 both sides, and we get the absolute value of x plus 3 is greater than or equal to 5. Now, the inside portion can either be a positive or a negative portion. So when we apply the positive, we get 3, or x plus 3 is greater than or equal to 5. X is greater than or equal to 2. And so that's one of our solutions. On the other side, we have a negative 5, so we have to change the sign. So it's x plus 3 less than or equal to a negative 5. And we subtract 3 from both sides, and we get x is less than or equal to a negative 8. So our solution is, in set builder notation, it's x such that x is less than or equal to a negative 8, or x is greater than or equal to 2. And we can put that in interval notation, parentheses negative infinity, comma, negative 8, bracket, union symbol, bracket, 2, comma, the infinity symbol, parentheses. That concludes our discussion on chapter 1.8. Please review the equation portion because those will be on your exam, or possibly be on your exam. There'll probably only be one problem, however. And please study. Thank you. Bye.